Hey there, it's Jason Gorman from Codemanship with a follow-up to the previous video diary entry that I did a couple of days ago that was about abstracting, essentially hiding the implementation details of your system from test code. And I refactored some test code that was, in this case, front-end tests that were driving a web application through the browser. What we did was we abstracted away the details of how we're actually manipulating the browser, so navigating to pages, so on. And there's a bit of a clue there as to what's happened as we abstract away all of the details of how we're actually interacting with the website behind this simple class called Basket Driver. And you can see that a whole bunch of imports have become unnecessary. We can get rid of those imports. Let's see if we can remember how we do that. Organize imports, Control-Alt-O, should remember that. Okay, so a whole bunch of dependencies on web pages and web elements and links and buttons, etc. They all disappear from our test code, which means our tests are now expressed at the level of creating a new session, ending a session, getting the total of a shopping basket. We'll take a look at the website in a minute to remind ourselves what that's about, adding products to the shopping basket, and so on and so forth. And if we take a look inside this class Basket Driver, you'll see all the nasty details of, in this case, we're using Selenium WebDriver, Selenium Chrome driver, to navigate to pages and get elements from pages and so on and so forth. And someone pointed out in a comment that this could have been written using a page object model as well. That's absolutely fine, but it's the same principle, which is you don't really want the test to know that these are web pages, that there are buttons, that there are links, and so on and so forth. Okay, so that's the stage we got to in the last video. Now I wanted to take this a little bit further. So once we've got this to this stage where the details, the underlying implementation details are hidden from the test code, there's more that we can do. There's more mileage we can make from this. And I wanted to demonstrate that, first of all, by extracting an interface from this this basket driver. So let's go to that refactoring extract interface, and I'm going to call it iBasket driver. We'll put it in its own file, I think, and we want basically all of the public members to be extracted into this interface. So we have a pure interface representation. Let's just go on and do that. Add, and I probably should. Let's just run the website and rerun those front-end tests just to make sure that it's still working. Actually, before I do that, there's a little bit of work I need to do here. So our test at the moment currently depends upon the class basket driver, but I only want it to depend on the interface, like so. Okay, so let's do that, and okay, let's apply those changes. And now I should be able to run our unit tests using Selenium Chrome driver. So you'll see some browsers pop up in a minute, and just to make sure that's all working. So this is just a general aside about when you're working with, for example, front-end tests or slow running tests or even manual testing, and you're doing refactoring, it's important to keep running those tests. You might not run them quite as often as you would if they were fast running unit tests, but it is important to be disciplined and keep testing the software when you're making changes to it. Okay, we're all good. All our tests are passing. Now, I've done essentially the change I've made here is that these tests are now working with the iBasket driver interface. And what I want to be able to do is essentially change the implementation of Basket driver and reuse the test. So this is a pattern called abstract test. It's really, really simple. So what I'm going to do is I'm going to extract a superclass from this class, and it's going to put all of the actual tests in there, and we'll probably do the setup and the quit part as well. So pretty much everything is going to go up into this this superclass, this super test class, if you like. There's all our different tests and that as well, but I'm going to make this abstract. I can't, come on. Am I allowed to make that abstract? Can I make that abstract? Yeah, I can. Can't make that abstract. Okay. Well, we'll take it up anyway, and we'll see in a minute what we can do. And again, we'll put it in its own file. And apply those changes. And we're going to, where's our test base? So this class we're going to make abstract. And of course, the refactoring has broken our code. I think what I'll need to do is stop running I think that's one of the changes that you'll actually have to stop running your web server for so that it can be applied. Okay, and what I'm going to do is I'm going to try and push this down into the subclass. Again, I want it, no, I can't do that. So instead, what I'm going to do is I'm just going to cut and paste this. So the idea is, if we go to our subclass there, and we'll just do it, we can do this in a constructor. So that's what we call it. And we'll need to make that protected. So the idea is that in the subclass, we can change the implementation of basket driver. So in this case, we've changed it to a, what are you complaining about? Oh, it's read only. Okay. Okay, so the idea is that we've got this abstract test class now, this base class, and we can't run these tests directly because it's abstract, can't be instantiated, but we can run them using the subclass here, which is going to use the basket driver implementation of that iBasket driver interface. I'll rename that in a minute. Okay, site can't be reached because I'm not running the web server. Okay, the rest of our tests appear to be passing, apart from that first one. Okay. So let's just take a look at our unit test there. Yeah, so let's rerun that one and make sure that one actually does pass when the web server is actually running them all again. Right. Okay. Okay, all our tests are passing. That's good news. And the idea is that we could create other subclasses. I'm just going to rename this actually. So let's rename you to basket web driver, or web basket driver, maybe a bit more. Okay, so we now have a web basket driver, so it's a bit more obvious what this one does. And the reason I've done that is I want to create another implementation of iBasket driver. So let's add a new class, and I'm going to call this model basket driver. So there is an internal model when we're driving the basket through our website. You don't like, oh yeah, it's doesn't like changing namespaces when you're still running the web server, can't keep up with that. And what we're going to do is we're going to implement the iBasket driver interface there, which means we will need to implement all of those methods. They'll just be dummies for now. Okay, right. So just dummies for now, not really doing much. But if we want to then create an implementation of this that actually talks to the model, if we take a look at a model, we've got a basket there, and that has a list of items essentially, and we can add products with a certain quantity to our basket, and we can fetch the total of the basket. And there are other things we can do here as well, like querying how many items there are in the basket. You'll notice there's a public auto property, so we can find out how many items are in the basket, and so on and so forth. So it should be possible to implement all of the features of our iBasket driver interface directly against the model. Now, that's going to take a little while. I don't want to bore you. So what I'll do is I'll just pause the video at this point, and I'll do this work, implement my iBasket driver interface directly against the model, and then we'll take a look at how that looks. Okay, so I've fleshed out my model basket driver here. So this is manipulating the internal data, the internal model directly. So when we create a new session, we create a new product list that recreates those 4 products that are on the website that I'm testing with the same prices and the same level of stock, etc. When we end the session, we just set our basket to null, simple as that. We can add products to the basket, looking in the product list basically to get the right product and adding one of those to the basket. We can check the number of the quantity of an item in the basket very easily there against the basket's items collection. We can get the stock count of a product from the product list and so on and so forth. So it's all populated now directly against the model. It's not going through the website. And what I can do now that I've got this is I can reuse my abstract test fixture there. Let's create a new test fixture and we'll call these, let's call them basket model tests. Or you can call them basket unit tests if you want to call them that. Okay. And of course, in a real project, we would probably package this file somewhere else away from our front-end tests so that we can run them independently. And all we need to do is extend our base class so it knows that these are tests. And then we need to give it the right kind of basket driver. So our basket driver here is a new model basket driver. Okay, and when we run these tests, now the thing to remember here is it's running exactly the same tests. They're the tests in the abstract test fixture there in that test base class. So it's the identical tests, but in this case, it's driving the model directly. So let's take a look and see if our model passes all of our tests. Fingers crossed it should. And indeed, you can see it does, and not quite naturally, these tests are running a lot faster. The point I wanted to make is these tests are identical. If we take a look, it's the original tests in the base class. So, you know, what is the total of an empty basket? What's the total of a single item, and so on and so forth. So the tests are identical, but in one setup, we're driving them through the browser. So it's pretty much end-to-end system tests. And in the other scenario, we're driving the model directly, but the tests mean the same things. It's the same actions that we're testing and the same outcomes that we're checking at the end. It's just that we're driving them differently. So essentially the same test, just 2 different setups. Same tests, 2 different setups. So if you go to the lengths of abstracting your test code away from the underlying implementation, it becomes possible to do things like this. It becomes possible, for example, to have the same test with different setups and essentially remove the knowledge of how it's actually driving the application from the tests themselves. So there was just a little bit extra, a little bit of bonus from the last video. So I hope you find that useful or thought-provoking. Until the next video, you take care. Oh, and don't forget to like and subscribe and ring that bell for notifications. See you soon.